All right, guys. Examples 3 and 4. Let's get the x-axis on them. That one and that one. All right. So in this one, we have transformations due to this negative and this 2. So 1 over x squared, the graph does this. This negative in front, it's going to reflect it downward. So it'll be like this instead. And that 2 is a vertical dilation. So all the y coordinates are going to be doubled. That's 2 times 1, this one that was on the parent function. So given that, let's go ahead and do a point or two. Domain, hopefully it's pretty straightforward. X cannot be 0. That is when your denominator here is equal to 0. So x cannot be 0. If you want an interval notation, it will be negative infinity to 0, parentheses, union with 0 to positive infinity. My range, it did not shift upward or downward. And it's going to look like this, since we're just flipping it upside down. So the range is going to be all the y coordinates less than 0. Interval notation would be negative infinity. That's the lowest. All the way up to 0, but never hitting it. All right, so let's pick a point on either branch. One for the left side here, one for the right. So let's go with negative 2. And then on the other side, we'll go positive 3. All right, so let's plug on in. So negative 2 divided by negative 2 squared. It's 4 on the bottom, 2 fourths, 1 half, so we get negative 1 half. So it's 1 point. Negative 2, negative 1 half, or about right here. You can pick more and more points. As you pick x's that are farther from 0, the y coordinate gets closer to 0. You get negative 1/4, 1/8, 0.0001, it gets smaller and smaller. As you pick x's closer to 0, the y values will get smaller and smaller, going towards negative infinity. All right. On the other end, let's plug in 3. So we got negative 2 over 3 squared. This will be negative 2/9. All right, so 1, 2, 3. 2/9 is much smaller than 1 half. Let's put it a bit closer. And similarly to the other branch, if you pick x's that are larger and larger, the y's get closer and closer to 0. Negative though, so negative 1/9, negative 1/18, and so forth and so forth. If you pick x's closer to 0, the y coordinates goes towards negative infinity. Negative 100, negative 1,000,000, and so on and so on. So there's the graph there. Still has the same horizontal asymptote. That has an equation of y equal to 0. And the same vertical asymptote. So those did not shift. And that has the equation x equal to 0. Those are your asymptotes, domain and range. And there's a graph for number 3. Let's go on over to number 4. All right, 1 over x plus 3. The only transformation we're going to have is this is going up 3 units. So if we go back to 1 over x, it's first example up there. 1 over x looks like this, where we have asymptotes at, let's take this out, a horizontal asymptote there, vertical asymptote there. The only difference for number 4 is that we're shifting it up 3 units. So 1, 2, 3 is where my horizontal asymptote is now going to occur. So at the line y equal to 3 is my horizontal asymptote. The vertical asymptote did not change. We did not shift left or right. So that's still going to be there. So x equal to 0. All right. From that, you can determine your domain and range. Domain, once again, x cannot be 0. Your range is slightly different. In fact, let's go ahead and graph this guy and then we'll discuss the range. All right. Let's pick a point or two on either side of that vertical asymptote. So let's go ahead and plug in. Now let's go -1. Make things a little bit easier. Plug in -1 into the function. We get 1 over -1 plus 3. -1 plus 3 resulting in 2. -1, 2 would be a point. All right. Pick x's that are further away from 0, -10, -100, and you will get y coordinates that get closer and closer to 3. 2.8, 2.9, 2.99999, and so forth and so forth. Never hitting 3 though. Pick x values closer to 0, -0.5, -0.1, so forth and so forth. You'll get y values that are very small, -100, -1,000,000, and so forth. So there's that branch. On the other side, let's just pick +1. 1 over 1 plus 3, resulting in 4. So at +1, we are at 4. All right. And if you want to plug in more points, the larger the x value gets, the closer to 3 the y value gets. 3.1, 3.01, 3.001, and so on and so on. Pick x values closer and closer to 0, the y values will explode going this way. So there is the graph there. The range, if we go from the very bottom, -infinity all the way up to 3, not including it. On the other end, it'll be very close to 3, and then shoot on up to towards infinity. So there's your range. You can write it as such with an interval with the union in the middle, or you can write it as, whoops, not x, any y's that are not equal to 3. There is number 4. There's your domain, your range, and your graph. So we just translated it upward. In future lessons, what we're going to see, a little bit of space, is this type of rational function. A lot of times will be written as one fraction. So we get a common denominator multiplied by x, top and bottom. You get 1 plus 3x over x. Usually the term with the higher degree is written first. It would look like that. And from that, you would determine the horizontal asymptotes with specific rules. Let's go over one of them real quick. If you had the same degree for the leading coefficient for the numerator and denominator, in this case 1 and 1, the horizontal asymptote, which is this purple line here, which is y equal to 3, will be always equal to the ratio of the leading coefficients 3 divided by 1 gives you this here, your horizontal asymptote. We'll get to that in much more detail later.